Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Semantic Research for sponsoring today's event. Semantic Research is an integral supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. You know, I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Alteryx, Tableau, HPE Vertica, Dell Statistica, and IBM, to name just a few. Now, past webinars are available on demand at datasciencecentral.com. And if you haven't had an opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. So today's webinar is entitled On-Demand Data Fusion for Single or Cross-Domain Visualizations. And before we begin this webinar, I'd like to briefly review the format. Today's event will be an hour long. We'll have one presenter that I'll introduce in just a minute. There'll be 10 or 15 minutes of Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, because we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speaker, Nick Obon of Semantic Research. You know, a graduate of University of Maryland College Park School of Engineering and a software engineer with 15 years experience, Nick has spent the past 10 years at Semantic Research as a professional services engineer, then Director of Technical Operations, and now Director of Innovative Solutions. So with almost a decade of direct customer and end user interaction, his expertise spans from data integration to the actual user experience of the software. Nick's comfortable whether writing SQL queries or advanced graphical front-end solutions. He specializes in Java, SQL, XML JSON data integration, and web services technology. He's supported missions across user spectrum to include counter-threat finance, counter-drug and human trafficking with supply chain analysis, intelligence-led policing, physical security, and counterterrorism. So Nick, thanks for being with us. We're looking forward to your presentation. Now, many companies have solved the challenge of how to capture, store, and manage data. The new challenge is keeping up with the rapidly growing data volume, then sifting through zettabytes of data to uncover insights to find value for the business. Even data-savvy employees find they can't easily access data and analytical insights when they need it most. The cost of integrating a new data source with a new data model is often prohibitive, meaning your platform can never move at the speed of your available data. So overcoming this challenge requires a solution with the ability to integrate data from all sources, internal, external, commercial, individual, emerging, and proprietary data sources, into a single environment for advanced analytics, whether they were planned from the start or weren't added until after the platform had already been launched. So in today's webinar, we'll talk about efficient methods of data integration and visualization, and you'll learn new ways to connect, analyze, and visualize data to deliver enhanced business value, deliver the analytic insights in a visual, easy-to-digest format to tell a story, identify gaps, and present actionable information in real time, how real-time data integration can occur in a flexible data model platform with no need for outside engineering help, and why leaving the data where it is opens the door for on-demand data fusion, the only kind that moves at the speed of your data. So Nick, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
All right, thank you, and good morning, good afternoon, everyone. Thank you, Bill. My name is Nick Obon with Semantic Research. I'm really excited to be here today to discuss on-demand data fusion, single or cross-domain visualizations. Excuse me. Some of the key takeaways today that I'd like to get the kind of frame in the mind of the audience is we're going to discuss the methodology of on-demand access versus acquire. So do you access your data or do you acquire your data? That's kind of one of our main platforms we're going to talk about. We're going to talk about having a flexible schema, a domain-agnostic schema capable of handling any kind of data you happen to encounter. Normalizing the ETL process, the extract, transform, and load process of your data across that flexible domain. And then the so what's, as I like to call them, gaining knowledge and making decisions from your data. Before we get too much further into the meat and potatoes, we're going to start with a poll question here for the audience to get a sense of where your current pain points are. So for the poll question for the audience, what best describes your current data fusion integration challenges? Is it, and please choose one, is it A, the flexibility of your platform, the cost of doing it, the accessibility of the data, maybe you don't even have access to it, or maybe the data integration is not so much of a big deal, but the current platform just doesn't meet your business needs for the data integration piece. I'll go ahead and count to 1, 2, 3. Let's look at the results. All right, cool. So looks like our audience, they got deep pockets. I love that. We got an audience of deep pockets. No one is afraid of the cost of data integration. That's great. But the flexibility of the platform is our number one answer. And in fact, there isn't even really a close second. Accessibility of data and current platform does not meet business needs are tied exactly at 26.3% for second and third. But flexibility of the platform, I love seeing that answer. We'll talk a lot about that today. Let's get in a little bit more here. And again, going back to some of our, the core kind of fundamental we'll talk about today of on-demand access versus acquire. I'm going to be showing a platform today that is based on the access model, which we're going to contend today is the only way to move at the speed of your data. Accessing available data when and only when you need it, rather than acquiring it, aka rehosting it in your own dust-collecting servers in a siloed repository. So this approach is particularly powerful at impacting cost, which we didn't care that much about, but it's worth noting. If you don't have to stand up your own closet of servers, that's always kind of a plus. Flexibility, that was our number one answer. Since you aren't a data warehouse, you don't need to worry about locking in your schema and solving your exact domain with only the data that you happen to have the foresight to bring in the first place. The quality is unmatched as long as you can maintain that uptime, because you can stay as real time as possible by always accessing the data on demand, as opposed to, say, running a job once a week or even once a night. I'm going to run my database back up at 3 a.m. Now it's 4 p.m. and my data is old. Maybe only half a day old, but it's old. And then the possibility piece, that's a nice one I like to emphasize there. A lot of times for a lot of the data providers, very high quality data providers that are out there, their business is making data available to you. They do not allow you to rehost it. We're talking about things like Thomson Reuters or TransUnion TLO, LexisNexis, social media sites. There's some legalities there on trying to duplicate and rehost social media data. All manner of data, transactional banking data, where there are strict rules against rehosting it, you must access. So it's not a matter of how much or how fast can you get it, but a simple matter of yes or no. The answer just might be no. You can't rehost our data. You have to access it. In that access environment, when you're not necessarily going to know ahead of time every field from every data source, you need the flexibility to tackle any domain. So the way to achieve that potentially could be to have a schema list data integration process where you have a network data model as opposed to perhaps your traditional rows and columns where it's entity-centric versus record-centric. The image on the right-hand side there shows kind of what I'm talking about, where you have these entities or concepts, be they a person, a place, a thing, a phone number, a transaction, anything at all that you might want to consider to be part of your domain or part of your ontology. I might use that word as well. And then those entities are going to be connected to other entities in your system. So for those of you that are familiar with a graph backend, right, that's basically what we're talking about here. We've got entities connected to other entities through some meaningful semantic relationship. So it's not just Nick knows Bill, maybe Nick is a coworker with Bill, things like that, where you actually can talk about semantically the relationship and the significance of that relationship between your entities. When you start thinking about your data that way, the actual content doesn't matter, whether you're doing people or communications, or if I'm semantically analyzing my grandmother's recipes so I can determine that butter is actually the root of all of her recipes. It doesn't really matter what my content is. I can now focus entirely just on the data type and the kind of integration that I need to do. So we can remove integration barriers, because when the data content is less important than the data source type, then barriers faced by domain-specific tools are removed, and all verticals become equally accessible. For instance, financial and transactional data, cyber, law enforcement, or maybe some of your business use cases, AML, fraud, compliance, and due diligence. An example I like to give there on the importance of being able to kind of forget your domain for a moment is a common scenario that comes up in the cyber realm, where perhaps I'm solving a cyber problem. I have a nefarious IP activity happening on my network, and if my tool is good, as many great tools are out there to do this, of network spoofing and being able to find the bad guy, what I've actually found is an IP address, and maybe if I'm really, really good, I did find a business, an ISP, an actual human being, a person that now I want to go gain additional insight and information on. Well, if your tool is stuck in the cyber realm, and you're going to have to tell your boss, oh, I can't look up a person because my tool doesn't know what a person is, that's going to be a less than ideal answer that you're giving your boss there. So a tool that takes the approach of I don't actually care about the domain so much as the type is going to be really, really flexible and pay big dividends. Just graphically to show what that kind of might feel like and look like, here we're normalizing the data ETL, the extract, transform, and load process. So up on the top-hand side there, I apologize, I think the slide got cut off, but this is structured data sources. So I might have databases, spreadsheets, CSVs, Excel files, HTML, JSON, or HTML. And yes, I actually do consider HTML to be just another structured data source. So any website you want to hit, to me, is a structured data site. You might have unstructured content into it, but we can get that later. Moving down here in the middle, you've got your commercial and your API-driven data sources. So you've got your LexisNexis, Accurance, your Thomson Reuters, Clear, your social media sources, Dun & Bradstreet for business needs, TransUnion, TLO for credit, all kinds of data sets in there that have a rigid API that you're going to have to go after in an access-only environment. And then you've got unstructured data sources as well. You've got previous stacks of paper reporting available to you. You've got live news feeds coming in from Bloomberg.com or your favorite blog here or Yelp reviews, whatever it is that you want to hit out on the website there. And then you've got email as well. Emails, images, videos, all kinds of kind of a catch-all of unstructured data sources. So if you take the approach of this is what I care about. I care about these 9 lines on the screen right now. I'm not actually interested necessarily in solving a financial problem yet or a cyber problem yet. I'll get to those. But first, let me solve these 9 lines, right? And I contend that if you do that, you're in really good shape here. So, we take a one-time extractor configuration for each type of data source, and you normalize that so that you turn all of those into a common output, a common operating environment where you're now going to be able to do in-app configuration transforming. So we did our extract, right? This is the top section there. Those 9 lines are the one-time extractor cost. Now I'm going to do some transform. Well, that becomes really easy, and it becomes a non-engineering problem, which is huge. It becomes a non-engineering problem when my users get to treat all 9 of these types of data sources as one common thing, right? And so I have in-app configuration transforms ability for me. And then at the bottom of the slide there, again, kind of getting to my so what's, well, I did this so I could then integrate the data and arrive at a number of compelling visualizations to help me tell my story and ultimately arrive at an answer. As Bill mentioned, my background is rather tactical, so I'm all about getting to that so what. I want to integrate this data so I can gain knowledge with a capital K and arrive at big insights. and then tell that story to someone else, right? So without further ado, I'm actually going to jump into the software here and talk a little bit about this slide as it relates to the software, the data integration and normalization process. Wait for a moment for the screen. I'm now sharing the screen. I'll note that, by the way, if you have trouble seeing the screen, you can always try to refresh your browser. I know sometimes that helps. But what's on the screen right now is our live software that's running on my machine, and this is our import manager. Again, I want to focus just on that last slide that was on there, talking about the types of data sets available. It's not important that you can read every word, and I apologize if you can't, but what is important is just the list on the left here where we've got, for instance, spreadsheet information that I've come in, so I can select one of those, hit the preview, and now I'm going to be previewing spreadsheet data formatted to look a little prettier, right? So this is a nice screen where I see individual records and I see all the data available to them. I can make this look less pretty and more like a spreadsheet by clicking the button in the top right-hand corner, and now you see there's the raw spreadsheet, okay? So we've converted, it's fine, that's easy. Take a spreadsheet, show me a spreadsheet. There's hardly any extracting to do there. The other major type of data format that we might want to look at is going to be XML. So you've got your comma-separated values, rows and columns, and then I've got JSON or XML. So I'll flip over to the next type of connector down here, and which is our President's Sample XML. Go ahead, hit preview on that, and you're going to see what XML is going to look like coming in, right? We have a number of records available on the screen. We've got George Washington versus John Adams versus Thomas Jefferson, etc. And we've broken the XML down and structured it that way. We're not limited, of course, to what's live, what's local on your machine. Here I can reach out, again, with just an XML connector to the treasury.gov website live. So we'll see how this goes with the screen share, hitting the internet live, going to treasury.gov to get their SDN list, the Sanctioned Designated Nationals list. So that pulled in from the internet, just an XML file hanging out there, right? No big deal. Just showing out that we can reach out. Again, we're accessing. I don't have to wonder if this SDN list is up to date because I just now accessed it from treasury.gov. Okay, that's again that access versus acquire. Moving on down the rounding out the structured data sets we talked about. Here I have a database query that I can preview. I'm running a live MySQL database on my machine right now, so I'll hit the preview button, show the preview. Again, rows and columns, no big deal, databases. Let's go ahead and bring up the different kinds of databases we might want to connect to. I know some of the audience members might be a little more technical savvy, so I can just show the connection screen here and how I have a connection wizard in the tool where I can connect to HSQL, Microsoft Access, Microsoft SQL Server, MySQL, Oracle, Postgres, all supported out of the box. We also have additional capabilities for things like Teradata, Cloudera, things of that nature. Some of your NoSQL solutions are also going to be wrapped by our services connector, which I'll get to next. All right, so we're going to just cancel out of that. Moving on to that services connector or a web connector. Again, I mentioned the HTML, JSON, and XML to me are all just structured data. So I think of no better website to hit live than BeerAdvocatecom. I don't know if there's any beer drinkers in the crowd. It is middle of the day, so hopefully not now, but I'm just now hitting live BeerAdvocate.com for their top 25 basic list of recommended beers. Current top ranking beer is Kentucky Brunch Brand Stout. When I ran this a month ago, it was a different beer. Again, I'm accessing this data live from the internet right now before your eyes. So, that's fun. What if I want to do some searching? Maybe I've got that same OFAC sanctions list that we saw before from the Treasury, but now I want to do some searches, and I'll just search Timchenko. Here is a classic example that was actually suggested in the autocomplete there. I can type, hit enter, and now not only am I accessing live, but I'm searching a service, a web service that the Treasury Department puts out for us to hit. And again, great, I see a pretty version. If you want to see what that looks like under the hood, we just click the button in the top right-hand corner, and I see that it's actually a table of data. Again, I've used my extractor to turn all data into this kind of common platform that a user might be able to come in and understand, and that's great. Other examples, I'll go ahead and just run through now. We've got the unstructured data that I mentioned on that slide. So here I have local documents on the left-hand side. I've indexed local documents. I can select one of those, see it in the middle of the screen here, getting highlighted with named entity recognition, NER, which is a built-in capability. We can discuss other capabilities later, but NER is what we have out of the box. So you can hit your unstructured data. And again, I'm going to turn unstructured data and structured as much as I can. So any of those entities that get extracted out become structured data. Then I have metadata like the source, the type of document, the size, the date, things of that nature. Same can be applied to emails, and I won't spend this too much time here because this is actually my actual inbox from a couple of years ago, but I can select my email inbox. I can look at emails. I can do things like show me top senders, top receivers, filter by date, all manner of activity there across emails. And then we have, rounding that set out, the images and videos as well. So here I have a bunch of food pictures. I am, in fact, Nick the Greek, so food is going to be kind of a big thing for me. I can look at one of those pictures here and rotate it clockwise and do all the things I want to do. Oh, wait, the screen, there we go. And then, you can see on the right-hand side, we've actually extracted metadata, trying to structure this as much as we can, even with a geotag that you see. This was a lovely Eggs Benedict breakfast that I had down in Key West, Florida. So it's geotagged there in the top right-hand corner down there to Florida, which is pretty cool. So making structure out of unstructured as much as possible, but not losing sight of the unstructured nature of it as well. With that in mind, continuing to step down here, I'm just going to do more of those arrows. We have unstructured documents that I want to be a little more particular about. Maybe you've got 20 years worth of reporting that is all roughly in the same format. They're PDFs or they're emails or they're Word docs. And you can tell me that they're semi-structured, right? There's this huge corpus of data out there that is semi-structured. And a lot of folks will tell you, oh, why is that hard? Isn't that structured? And so I say, yeah, that actually is not too hard. So things like access logs, for instance, in your cyber realm. I'm going to browse to an access log here and actually use my Mac's Quick Look to show you what that access log looks like natively. So here we have semi-structured data, right? This is just a text file, but it's pretty semi-structured. There's clearly rows of data here. They're separated by characters. There's formatting in here, things of that nature. So we're able to make it so that you can take that semi-structured data and write quick parsers, select the document, bring it up and preview it in the document parser module itself, again, turning that into rows and columns that now a user can come in and map that data and turn it into something meaningful. Great. I'm just going to round out the rest of these by kind of moving down here. I don't want to take too much time and go through every possible connector. That would take all the time we have, and I do want to get to the so what. But here we've got a set of cyber-related and social media-related sources. So I've got Whois as an IP address lookup, Facebook parsers, YouTube parser, Instagram, Twitter, Flickr, Yelp. I'll go ahead and do a Yelp search just because that's fun. Come in here. Chipotle, see if I can spell that correctly. And I'm looking for Chipotle in Tampa. I'm actually down here in the greater Tampa area. So I'm going to run that. Again, live internet search on the fly, trying to find all Chipotles in the Tampa area according to Yelp. Here they come up. They all have the lovely Tampa addresses, the Chipotle logo. I can actually go get additional information as a secondary parser by clicking the button in the top right-hand corner of any one of those records here. And so I do that, spin it off. It's actually going to go get reviews live for that particular restaurant. We've got complete things like the user that did it, what they said, the rating they gave it. Again, all of this marked up with named entity recognition, NER capabilities. So that's lovely. Again, the idea of accessing versus acquiring. This is going to be the most recent, up-to-date activity and data that I can get my hands on. And folks like Facebook and Yelp and YouTube and Twitter look down on you rehosting all of their data. Their data is their product, so don't do that. Okay? Very good. We're moving on here. We've got some commercial data sets. I won't run through all of these, but we've got clear in here. We've got TransUnion, TLO. Clear, there's business, phone, vehicle, person, watercraft. Any domain you want to do is fair game, right? Because we're taking this approach of I'm going to focus more on the type of connector, not necessarily the domain. TransUnion, TLO, Dun & Bradstreet for your business needs, things of that nature. If you look down the list that I just hit, again, hitting on that flexibility, emphasizing the infinite domains possible, we're looking at any spreadsheet you can imagine, any database you can imagine, any XML file that you can imagine, any website that you can imagine, right? The world is your oyster. If there's data out there, go get it. Go access that data. Don't worry about standing up your own server farm to try to worry about rehosting it. Just go get it live on the fly, okay? I'm going to point out as a very particular domain set that I've got here, near and dear to my heart. Bill mentioned my previous government experience. I did a lot of counter-trafficking missions, so I've got a whole set of aviation sources here, hitting websites that either pull down information about planes or photos about planes, and I'll be kind of demonstrating that towards the end of the demo. Towards the bottom here, I've just got a whole handful of other websites that we've connected to. Again, I don't want to take too much time going through every nook and cranny, but pointing out my list goes on and on here of different websites that I've connected to. So I've got maritime websites here. I've got cyber-based websites where the blockchain for Bitcoin, if anyone uses Bitcoin out there, a lot of those transactions are actually available for lookup on the web. I've got cyber-focused things here hitting IP addresses. I've got business lookups, Edgar and U.S. Digital Registry. I've got advanced Google searches using the Google API, Wikipedia. We've got law enforcement things like Bureau of Prisons, company lookups like Companies House and Glassdoor and Sunbiz, a whole host of websites. Again, pick your domain, tell me what your problem is, and let's go get that data, right? That's the approach that we're taking here. Through this UI, through this experience, not as an engineer, but as a user of the application. And that's an important point here. The last 5 on the screen there was kind of the magnifying glass icon, if you can see those. Those are going to be my configured federated searches because what good is data integration on demand if you're stuck one at a time? I was showing them one at a time on purpose to kind of give you a sense of what's possible. But of course, I want to search 20 sources at once. I want to know everything about Nick Obon, not just one thing at a time. Here's his Facebook page. Okay. Now here's his Twitter. Okay. Things of that nature. So I'm going to be demonstrating a federated search towards the end of the call, but I wanted to head that off before I got too many questions about how do I do federated searching. Yes, you can do it. You configure it right here in the application, and you use it in the main screen, which we'll get to next. First, I want to go ahead and jump back over to the slides and talk about what we're going to get to, those so whats that I want to get to. But that was, again, major takeaway there, access versus acquire, flexible schema. I don't really care about what kind of data you want to look at. I care about the type of data integration you want to do. Are you hitting a spreadsheet versus a database versus an XML file? Are you hitting unstructured documents versus emails versus photos? Are you hitting paid commercial data sources or online access-only data endpoints? REST services, things of that nature. All that possible right here, configuration in the application. So, fantastic. I'm going to stop showing the screen and move on to my next slide here. I am an engineer by nature, so this will be one of the last slides that you see by me, and I'll get back into the software. But I want to get to those last 2 so whats. Gaining knowledge with a capital K and making decisions. So we have all the data, right? Right, that's great. We got a lot of data, and even if you don't have a platform like this, I bet you have lots of data. I bet you've got your whole warehouse set, you've got your transactions, you've got your personnel records, you've got a whole bunch of data, and that's great. What about knowledge? What about insights that you can use, knowledge you can use? So once you convert data from any source and any domain on demand into a common operating picture, what should that picture look like, right? And that's an interesting question. So we've got a number of very traditional answers for you here, and then we can maybe get into some ones that are a little more innovative. So link analysis, right? Link analysis is a great way, especially if you've got a network data model like we do. It's a very traditional and intuitive way to discover relationships in your data. How is Nick related to Bill? Then you've got charts, so you can get more familiar with the stories told by the numbers, the dates, and other chartable metrics in your data. You've got maps for domains with location-heavy data, supply chains, businesses trying to operate multiple branches, law enforcement going after particular regions, or maybe bounding box queries for social media, trying to get a temperament and a sentiment for how activity is playing out. A lot of location-heavy domains, and there's nothing better than seeing that on a map, right? And then you've got timelines, understanding when events occur and what the flow of information is going to look like. So those are some kind of visualizations that I want to be able to step through here. Again, kind of moving on from the data integration portion and getting into more of a so what. So I will share the screen again. Very good. And again, if you have any trouble seeing the screen, try refreshing your browser. That may help. What you're looking at now is actually the core desktop application. So but before, that was all import configuration that can happen in the application. We can add new sources there. We can map that data in. We turned all of that data through its extractors into a common structure and a common format, which then becomes really easy to normalize into my actual analysis platform. Now we're going to walk through a couple of use cases and a couple of examples of what I do with that data once I've got it into my system. We have a number of stories to tell. We're going to start with that Bitcoin example. And if Bitcoin is not for you, hold on for 3 minutes. We'll be on to something else. Don't worry. So I'm going to show a Bitcoin. This is a Bitcoin address. For those that may not be familiar, this is basically a unique ID for a particular user or transaction, something like that, in the Bitcoin financial transaction space. I can actually run live access points right here from the application by right-clicking on that address and running what we call a workflow. So workflow is available here. I have a whole bunch of them. You might not even be able to read them on the screen, but one of them says blockchain info. This is going to run that blockchain parser we saw before in my list of sources. So I'm going to go ahead and run that. It's going to do a live internet query, pull in what it can from the blockchain address lookup, and here I have a set of transactions and relationships in a very traditional link chart view. Okay, so that's phenomenal. That's great. We carry that access of data through the use of the product, not just in your initial discovery phase, which is very important. This idea of iterative discovery in order to tell a story and understand and gain knowledge is a big part, a big piece of what we like to do at Semantic Research. I'm going to go ahead and flip over just by hitting the right arrow on my screen to another visualization. Same story here, same story I'm telling, still Bitcoin, but I basically have as many of these views as I want in the nodal link chart space. And we're just looking at nodal link chart stuff for now. Here I have a timeline of a bunch of transactions. I'm going to go ahead and hit the play button on my timeline in the right-hand corner there, and you're going to see those transactions start to play out. And this is where you have your picture, or in this case, live animated picture, being worth 1,000 words approximately, where you see the transactional flow, and then a spike of activity pops up, and then lo and behold, by the end of that spike, I actually end up back where I started. This is great for seeing transactions play out and how those things are connected over time. So just an example of classic link chart analysis with pretty colors and timelines and all of that stuff we might want to get to. Excuse me. Moving on, but staying in the temporal world here, we have another view. I've just minimized that one and moved on to another investigation. This is violent crime activity. Okay, so if Bitcoin wasn't for you, violent crime is next, and if violent crime is not for you, don't worry, we're just going to move through these. Okay, from here now, we have this really neat view called the event analytics view. Again, I can bring all this data in from any kind of data source and view it however I like. We call this event analytics. Event analytics is a fancy word for calendar, right? I don't know about you, but I organized this call on my calendar because that's how me, as a human being, likes to think about temporal events. So here we have a calendar view. This would happen to be civilian attacks by month broken down, so not a particularly lighthearted topic. But again, visualizations can tell a very compelling story. I can see right away that there's actually nexus of activity here in November and December. I happen to have November and December be the top left hand corner of the year I'm looking at, and then September and October of the following year. So this is November and December of 2014 up here on the top left, and September and October of 2015 in the bottom right. I happen to know that where these attacks occurred, weather probably played a large force in the amount of crime that occurred, which is a common phenomenon. And here we see that this part of the country is very temperate and very pleasant during the fall and winter months. And during the summer, it's going to be raining every day and 98 degrees. And so you see this basic dirge of activity, this almost lacking of activity starting around May all the way through August, and then it picks up in the fall through the winter. So again, that's kind of interesting. If I'm doing tactical analysis, if I'm doing planning, resource allocation, maybe this is an important story for me to tell to my superiors and whatnot. So that's a good one over time. I can also zoom in on this, just getting more into the actual UI experience. I can click on one of those dates there in September of 2015, see the event that occurred over on the right-hand side. I can maybe go down to just saying I want to see 4 months of data centered around that month, so I can do that. I point out here now it's probably easier to see. We do have a temporal heat map. I know folks are very familiar probably with geospatial heat maps. The idea of geospatial density is a big one. We have a temporal or event density visualization here as well. Dates that are white have no activity. The lighter colored the date, the less activity is. And if I select, perhaps a date that's darker, here September 25th, select it. There we go. Then I've got more activity showing up on the right-hand side there. You've got three crimes on that one day. So again, this is kind of a nice way of seeing it. Or if a single month is more your style, you can flip down to a single month, focus just on the selected month there, and now you're looking at just September, where you actually have the individual events played out on a month's calendar basis, which is a lot of fun. All right, very good. There's our violent crime temporal analysis. Again, I promise I'm going to try to do about 3 to 5 minutes on each of these, and if it's not for you, hold on. We'll wait for the next one. So we're going to go now to a more financial realm. This is going to be banking and financial data that's on the screen now. Again, starting in a big, nasty link chart. Look at that thing. If you're looking at the screen now and you say, wow, Nick, that is a lot of lines and nodes. What do I do with that? I agree with you. I agree. That's not necessarily the best way that I want to visualize this particular data. Maybe I'm going to be able to grab a bunch of insights like, hey, there's a really giant nexus in the middle. If I zoom in, maybe I'll see that there are 4 or 5 kind of super hubs that have a lot of activity. Along the bottom there, I've got kind of their own little mini clouds. Those are potentially interesting to me. So maybe I know about my data at this point, but I don't really know, I can't draw tactical conclusions about it. So I'm going to switch over for the first time now, and we'll look at the analysis view, because we do turn all data, no matter where it came from. I identified those 9 types of data, and those 9 types of data were all extracted out into a common platform, and that common platform was then able to be mapped into a semantic network. So column A is connected to column B, right? Things of that nature. Because we turn, no matter what the data is, into a semantic network, whether doing finances or doing my grandmother's recipe for baklava, I can do network analysis on it, which is really cool. It was really powerful. So I took that big hairball of network activity and turned it into a network centrality statistics breakdown, which we see here. And right away, now I can tell you, hey, Bank of Jackson, this is all fabricated data, so there is no actual Bank of Jackson. Don't go joining an account there. But Bank of Jackson rolls up to the top right away with regard to this one network centrality statistic. John Paul Jones Financial, there is number 2. 2 top banks in my transactional information here, followed then by a number of companies. So I can come over here and say, hey, this set here are very interesting companies to me. I'm going to go ahead and highlight those. I can hit the space bar to look at one company at a time or the whole group. So hit the space bar, I get my quick look, what we call quick look. If you're a Mac user, you'll be familiar with quick look. We have it in the application for both Mac and PC. So you can get a sense of that one entity. You can browse through those entities and kind of see what I want to know about them, or I can just look at all of them across as a set, right? And I can take from here and send them to other places for follow-on investigations. So that's fun. By turning all data into a network through that common access point, we can do fun things like this, and maybe identify, hey, I do want to investigate maybe those top 2 businesses, right? So I'm going to go ahead again. I can have as many of these visualizations as I want. I'm going to just hit the right arrow on my keyboard, hop on over to another analysis view where I'm looking at the frequency of transactions. Given I know what's important in my network, I can now look at, hey, how active are these guys? So West Texas Energy Group, probably too small to read, but just take my word for it. This was one of those top companies. West Texas Energy Group by far is the most active participant. So now I'm looking at frequency of events. I called Bill, right? I called Bill 2 times, right? I called Bill 17 times inside of 1 hour. Those are 3 very different statements, and they mean very different things. The last one means I have a problem, and Bill needs to stop taking my phone calls, for sure. But the idea here of the frequency at which, the rate at which something occurs potentially is very important to me. So here I have this frequency analysis here. I can look at West Texas Energy Group having 134 transactions with check. The recipient of that transaction was check, right? So this guy is just writing a bunch of cash checks to himself, as it turns out. And we have a starting point from early 2014 to early 2016. So maybe I want to take those 134 charts and 134 transactions and now kind of look at that over more of a charting thing. Hey, show me the amounts of those transactions over time. Again, all I did there was hit the right arrow on my keyboard. I'm going to try not to drive too much of the app here. This is not meant to be an application training session by any means. I'm just trying to give you a feel for what you do when you have access versus acquired data. With access to throwing it on there, and I see that early 2014 to early 2016 transactions and what those look like. So from here, I notice, hey, I've got an outlier all the way to the left there. Maybe that's interesting. Obviously, I've got some spikes. Those are interesting to me as well. All right, cool. I'm checking my time here, and I'm going to go ahead and move on. Financial transaction, hopefully that was interesting. Moving on to my next guy here, geospatial data. This is going to be border crossing data. I'm going to throw this up on the screen. Border crossing data is, again, near and dear to my heart as a counter-trafficking idea here. And look, we've got geospatial visualizations. All of this was accessed from a number of different data sets, a number of different data warehouses, accessed, brought into the platform. And now I can come over here and add my located information just by selecting one drop down there, add located data, bring it on. I've got points on the map. What's even more interesting is I don't need to lose the semantic relevance of those points. I can actually drag and drop people onto the map. So these, the locations there were going to be addresses and border crossing events. The people themselves didn't have geospatial activity, but maybe they're still related to those events. So I don't lose track of the contextual or semantic relevance of my geospatial data. We're not trying to compete with Esri. Esri is a great tool. Even Google Earth, great tool. But in order to use those, you got to have a location for every single thing. Here, the idea is we're going to throw some stuff on the map if it happens to be there. If it's not located, we'll just have it floating in space so you don't lose track of the contextual importance. Last piece here I want to show is cyber world, cyber data. I mentioned that a couple times already. We've got color-coded, rule-based analysis here now. So these colors are based on rules, semantic rules that I have identified as threatening behavior versus okay behavior. I also want to point out data fusion at this point where I can filter this view according to the data source that it came from. So I'm going to go ahead and hit the filter button there on the toolbar. And along the source side here, I can look at information that came in, for instance, from the website IPIliad versus, wait for that, there you go, versus the Whois website over here versus maybe my own personal access logs, things of that nature. So we can filter that information. Again, using data, accessing all of this was, none of it sitting in a siloed repository. All of this is information I had to reach out and grab from a live website or maybe a local file that I happen to have access to. But I fused it into this one picture, which tells me my network story, which is very important. I'm going to take my last 2 minutes here before we get into Q&A. I promised to show federated searching, and here is the point. Here is the access versus acquire thing. I am going to do a soup to nuts investigation in 1.5 minutes by clicking on File, New, up here, opening up a new file, which I'm probably going to have to adjust the size of. That's going to take up half my time right there. All right. I'm going to go over to my Discover workspace, one of the last things we didn't show. The Discover workspace is where we can see those federated searches. Here are my 5 aviation sites, 5 aviation. They're all live websites, either photo websites, registration websites. The FAA is actually in there, and I'm going to hit it live on the fly right now for a tail number that I happen to know is a fairly benign, non-criminal activity tail number. Tail number is the registration of a plane, similar to how your car has a license plate. Okay, I'm going to hit the search after putting in my one tail number button there, and we're going to, that's going to run, hitting the internet, live on the fly. I'm pulling down pictures here. Wait for the screen to go. There's some pictures coming in. Maybe I like this one. Maybe I like that one. I also have registration information from the FAA. Very good. I'm going to import that and send it to a new network view. Okay. Importing, again, here's data fusion, on-demand data fusion. I want to know about this plane right now, importing it, sending it to a new network view visualization. There's my guy. And now the real so what is you're my boss. You asked me about this plane, and I'm going to go ahead and do file report and generate a report, customizable report, of course, on that aircraft. So I select registration report. I type in my registration. I want to include the network view. I could configure the report here and add a note if I wanted to and whatnot. There it is. I won't bother. I hit OK, and I'm going to go ahead and hit generate. And here we have on the screen now a custom report generated right there. I mean, you just saw it. I did the search, pulled in the data, generated a network view, and here I have registration data, I have pictures, I have sourcing, I have activity logs, I have, there's my network view visualization, which of course I could have gussied up, I could have put notes on the screen, I could have done all the things you'd expect to do from a link analysis tool. But that was, I'll call it maybe a solid 2 minutes of doing data fusion on demand, going soup to nuts from a question to a report, which I think is a great thing. With that, I think I'm bumping up against my time, so I will stop my screen share here, bump on over, and Mr. Bill, if you would like to take the con again for our Q&A session, I will be happy to take some questions.
Hey, Nick, thanks so much for that excellent presentation. And we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in during this presentation, so we'll do our best to get through all of them in the time remaining. And during this Q&A, I'll leave up this screen with contact information for Nick if you'd like to contact him following today's event. So let's get started. Nick, a lot of questions have come in about bringing in different types of data. A lot of the questions focus on unstructured data. I have a couple of questions about unstructured and data in general. So let's start with when you pull in unstructured data, are you using optical character recognition or NLP, or what techniques are you using?
Thanks, Bill. That's a great question. Early on, I gave a teaser right on some unstructured capabilities, and I mentioned very specifically named entity recognition, NER. That is what we ship with by default. However, we have a number of phenomenal NLP and OCR partners. We take a similar approach, much like our on-demand access of data. We take a similar approach for specialized capabilities like that. So natural language processing, OCR, geocoding, and a number of others that are really a very specialized capability. We basically treated plugins that you can do live on the fly when you ingest or prior to ingest as you would for a document set. For OCR, we do ship with the free and open source product called Tesseract, so you can perform OCR on your scanned PDFs. We also have Microsoft Bing for translation. That's another one that we like to plug in. And for NLP, we have a number of partners ranging from ones that probably half the industry has heard about, all the way down to the little guy. It's super easy to plug more of those in, but we treat those as a service that you can access on demand, very similar to our data approach. And the answer is yes, we do ship with several of them standard.
Well, Nick, thanks for that answer. And the audience is asking us to drill down into that a little bit with some specific questions, two of which are, would this work with Twitter with hashtag searches? And could I bring in Google Analytic data as a data source?
Yeah, great question. So, I think we've got a couple of webinars that we need to schedule here on getting into the individual domains. The social media world is a fascinating one. I love it. We live in a peep culture today. Of course, the 80s and 90s were pop culture. We're in a peep culture now, so I want you to see me, right? I want you to peep on me, right? And so, yes, we have full integration for, I'll call them the big five social media sites out there. Twitter is probably the number one, followed by Facebook. And so we have hashtag extraction. We have sentiment analysis, again, through one of our partners on tweets. You can do bounding box queries of your tweets, assuming folks, of course, have their location services turned on. We're not hacking into anyone's anything. But if you're tweeting about the Tampa Bay Lightning because you're at the hockey game and your location services are turned on, we will see you right there at Amelia Arena. But yes, absolutely, we can handle that. On the Google Analytics side, great question there, because they do some phenomenal work. We do have a full integration with the standard search API, so the one that lets you kind of tailor your searches a little more. We haven't done Google Analytics, but I'm familiar with it, and I believe they expose a number of REST endpoints, and so we would go after that just like any other flexible data source, like we hit Yelp that I showed, where that's a REST API as well. So yes, we could do that as well.
Well, Nick, thanks. And there is one more drill down I'd like to surface, though this may be more about NLP capability than about your platform. And that is, let's say that we're looking at a number of texts that have numbers inside. And for example, one of them talks about consumption of cognac per person per month, but a similar text talks about consumptions of per family per year. Could your NLP differentiate that and build a table that would split those out, or is this really just a deep NLP question?
Yeah, so that is more of an NLP question. However, you're getting onto relationship extraction and the semantic relevance of how these extracted entities are related to each other, which is right up our alley. We have one. I don't want to give anyone a shameless plug. But we have one partner that does what I think is the best of breed relationship extraction. And folks, feel free to reach out to me afterwards if we want to talk more about that. And the nice thing about relationship extraction is, well, hey, that's our data model, right? So if you tell me that you do relationship extraction, you're a best in breed NLP capability, and you not only find entities, but you also find relationship, sentiment, and confidence on those relationships, I will show those as quickly as I will show anything else, because relationships is what we want to put on the screen and what we're really good at visualizing, which is a lot of fun there. Also worth noting that because of our approach to partnering with these folks, next year, when invariably NLP has done better, some new company comes out of Silicon Valley or some new company comes out of DC or here in Tampa, and you identify, hey, Nick, I love your platform. I want to start using this new NLP capability. That becomes the flip of a switch. No problem. That's another thing of, again, capability access versus acquire is going to pay you back there. Because as the capabilities of our partners get better, you can always go back and pick your best of breed.
Yeah, right. Terrific. Thank you for that answer. On to the issue of data sources. Boy, it looked like there wasn't anything that you couldn't access, but is it possible or easy for users to build their own data connector, or is that something that semantic research has to do for them? Absolutely.
So there's two levels there, and I'm an engineer, so I won't ever sell you something that doesn't exist. So there's two levels. There's that top of that slide, if you can remember that data connector slide. If you're talking about connecting to a brand new type of data that we have never seen, of which I'm here to tell you in the last maybe 2 years, I haven't encountered one, right? We've been around for over 15 years. We stay up on the tech. So I'm here to tell you that I'm pretty sure we can hit any data connector out there. at this point. But let's say you invented a brand new type of data source. You would then need to actually write code for that one-time extractor expense to be able to hit that brand new type of data and extract it. After that, there is a big fat tear line, and I expect users and analysts and subject matter experts to be the ones building the actual no-kidding bridge between the type of data and the end products there. So if you've got a new spreadsheet, just as a simple example, obviously a user is just going to drag and drop that spreadsheet in. It's going to say, hey, I don't recognize this spreadsheet. Would you like to make a new connection? Then the user says yes. They click through a wizard. They say column A is a person, column B is a phone number, and guess what? They're related via that's the person's phone number. And every data connector we have like that has a UI to it to help the user build it. It does get a little more technical if you want to get into the JSON web services, right? You're going to have to not be afraid of JSON. You are going to see JSON on the screen or XML, but all that's done in the application, not in some dusty corner by an engineer drinking Mountain Dew and eating Funyuns, which is what I like to do.
Thanks, Nick, for that clarification. Let's talk about the output side of your platform. What sort of predictive analytic capabilities do you support beyond what you've shown us?
Sure. So we've got all the charting out there that we discussed, and we have, and I'm very excited about this, just late last year have integrated R, the statistical library with its predictive modeling capabilities. R, for those of you that are not familiar with R, go check it out. It's very exciting, very cool, and of course it is what happens when pirates do math. R, bad joke of the day. You're welcome. So with that, you can take your data, if it is statistical in nature, especially. It's difficult to do predictive modeling over my grandmother's recipes for baklava, but if you've got your financial transactions, or even we have a phenomenal data set that I just recently did, which was the Fragile State Index. This is a world consortium that puts out the stability of various nation states according to 10 different metrics like refugees and the health of the economy and all kinds of stuff. And you want to do probability metrics on that, like, hey, top 20 countries, are they going to be the top 20 countries next year? When you've got numbers and you've got temporal bounding, you can use R. You just drag and drop it onto our R integration area, and it's going to generate future plots for you in the same way that we can do current plots today.
Well, thanks. R and pirate analytics. Well, Nick, thanks for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all those unanswered questions to Nick and the Semantic Research team so they can follow up with you after today's webinar. I have just a couple of quick announcements. If you'd please mark your calendar for March 28th, that's next week. That's our next DSC webinar, which is going to be Apache Spark and IBM Streams working together in streaming analytics, be presented by IBM. Well, this brings our webinar today to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Semantic Research for their sponsorship, and our speaker today, Nick Obon, for his insight into today's topic. My name is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on March 28th. Have a great day.